Hey guys, welcome to business statistics class. If you're watching this video, that means you're in business statistics. If this is not the class you signed up for, feel free to walk out now because I wouldn't know. Just a little about me because I know I'm probably a stranger to most of you. My name is Mr. Harris. I'm going to be teaching the class via video just because I wish I could be there with you guys, but my schedule just can't allow it. I have to work during class time, so I'll be there, in spirit and in virtual format. So if you have any questions, don't ask the video, ask Mrs. Bernardi. She can help you out. But feel free to email me or text me, or you may have I think Mrs. Bernardi has all my contact information, so you can just ask her for that if you have any questions, but please feel free to reach out to me for any questions. A little bit about me though. I'm originally from Northwest Arkansas. Recently graduated college from the University of Arkansas with a mathematics degree. Very soon hope to be starting my master's degree in analytics from Georgia Tech, which I'm excited about. And I've grown up my whole life loving numbers, and so I hope you guys learned something from me, and I hope to also learn something from this class as well, because I'm excited. So really, let's just get started. The real question how we get started is, what is statistics? Because I know a lot of people have a very weird misconception about what statistics is. A lot of people think it's just math and numbers and just a lot of different unnecessary things that people use for no reason at all. But the way I see it is it can connect, let's say 21, 38, 45, 68, four seemingly random numbers. You have no idea what they mean. But in terms of statistics, if we could find a connection between 21 and 45, it helps us drive business, okay? It helps us make decisions that impact our business in a positive way. That's all statistics is, really. It's analyzing, collecting data, and then interpreting it. And in this class, that's what we're going to be doing. We're going to find ways to analyze data, or data, however you prefer to say it, and what that can do for business. It can just allow businesses to take appropriate action to improve their business practices, because, let's face it, information is key. And if managers and CEOs know what's going on in their business, sales, production, all that stuff, it can really benefit them in a positive way. And they do that by statistics. So, and especially in this technological day and age, analytics is becoming more and more popular. You see it in sports, you see it in business, you see it in school, you see it in church, believe it or not. Hey, NOC College. Let's see. And if that trend continues, this is just going to be much more of an important class for you guys, because if you can prove that you're that valuable of an employee in the business world, you're going to be that much better and easier to hire. Currently right now I work at a company called Insight, which is an IT company. We handle a lot of big data for a lot of big companies. I do data analysis on the daily. I make sure numbers are right, big databases are correct. I just maintain the accuracy of those databases. So I deal with numbers a lot, and so I hope you can trust that I know what I'm talking about. And if I don't, I'll figure it out. So we're in this together. But really what I wanted to get down to was just kind of the difference between, a lot of people can get statistics and a statistic mixed up. And so what I wanted just to talk about was statistics. Like I said earlier, it's just a way of analyzing, collecting data, interpreting data, right? It's just generally as a whole, the science behind analyzing data. A statistic is like I said, the number behind the statistics, right? A certain data point that we're trying to interpret, okay? For instance, let's say, we have a college gown manufacturer, because I know a lot of you may be graduating soon, which is awesome, right? and they need to know how long to make their college graduation gowns because they don't know. Well, if I took a straw poll in this class and just took down all of your heights, right, what would be the best way in order for him to kind of figure out how long to make the gowns? Well, if you said take the average of the heights, you'd probably be right? So it's just an average of the heights. We can do that, and he can get it out, right? Or another application, let's say we're building another church campus, because I know that we build them a lot. And we need to know how tall to make the doors, right? Because Tyron's a pretty tall dude, so he needs to fit in those doors, right? So I'd probably find, like I said, record the height, and I'd find the tallest person in there, and I'd make a door that he could fit under, or she. So just another way that we can use statistics, right? Seemingly random numbers that really don't mean anything, we can use to connect in a lot of different ways, right? Same statistic, but we can still use it to ask different questions, pose different analyses, and all that stuff. So I hope it's cool. Yeah, I hope it's cool. I find this interesting, right? Okay. But in this case, a lot of times, a lot of people don't really understand like why we study statistics, right? They don't really understand the why behind the what, okay? But in any case, statistics is one of those things that can really help you as an individual, as an employee, or as an all-around person, really. It helps with communication, right? Communicating with numbers is a hard thing to do. And if you can communicate with numbers, you can communicate with words, in my opinion, I think. I'm not good with words, but I'm good with numbers. That helps me communicate with words, okay? Computer skills. I use software every day to put these numbers in a database, to analyze, to query data, all that stuff, right? So the more we're able to use statistics, the better we are able to use the computers that help drive the knowledge to use the statistics, okay? Information management, another huge one, okay? There's a lot of statistics, or a lot of big databases in business, right? And like I said, it's my job to maintain the accuracy of those databases. And we maintain a parts database in our system that's probably easily over 1 million parts, right? Learning how to manage that, learning how to keep those accurate, which is a heavy job. Someone's got to do it, right? The last thing statistics help us do, process improvement, right? The thing we always get asked as a company and as a business, how do we make our processes better? How do we make our processes faster? It can help us improve processes and just help things run a lot smoother. And so that's just some of the reasons why we study statistics. There are a lot more. But like I said, we only have 8 weeks to learn all this stuff, so we don't have a lot of time. I'm just going over the main key points. Also, reminder, we are using a textbook. We have a book here. I hope you've gotten it already. If not, no big deal. But it's the Applied Statistics in Business and Economics. I'm pretty sure Mrs. Bernardi has already put it on the Google Classroom for you. Please get this book. This is what this information comes from, okay? Please get it. We'll be using it a lot, okay? Like I said, statistics in business, okay? What do we use it and what do we use it for in business, right? I've mentioned some of the things that I do. There's a lot of different things that other companies do, like they can audit their books, they can audit their company, stuff like that. Marketing. How does a church market to people, right? They have to go by the numbers. If we're not reaching a certain demographic of people, we can look at that and say, okay, well, what's the problem? Why aren't we reaching that? And that's how we can use marketing, okay? Healthcare, big one. Quality improvement, right? How do we make something better? Because nothing is perfect, right? We always want to improve on it, make it better. Purchasing, right? Unfortunately, our country, I think, lacks in that knowledge of purchasing because we're in trillions of dollars of debt. But purchasing, we never want to spend too much. We always want to make sure that we're budgeting the right amount, spending the right amount, not overspending, stuff like that. Medicinal purposes, right? Stuff like that. How do we get the right medicine, the right combinations of pills, all that stuff. operations management, stuff like that, product warranties. These are some like really vague aspects of business that can be applied to statistics, but there are tons more. What we're going to do right now, like I said, I don't believe in talking a bunch because I'd rather, the best way to learn is by doing or teaching, and since you're not teaching, you're doing. I want you guys to actually do something. So we're going to do a couple examples right now. They should be thrown up on the PowerPoint right after this, but go ahead and pause the video, work through a couple of them, and I'll see you back in a second. All right, so you've talked about some business applications for yourself. We're going to get back to some challenges that can kind of come into play with statistics. There's a lot of them, especially in business. We can come into a lot of challenges in terms of how we do business, how we handle data, all that stuff. Ethics come into play. The biggest challenge that you can face is imperfect data, because the biggest thing you can do is give someone 90% of a picture, right? You wouldn't pay for 90% of a picture. You wouldn't pay for 90% of a movie. You wouldn't pay for 90% of a meal, right? We can't do this. We can't do that for data either. We have to give them the whole picture, or else it's not accurate. Okay. Ethically, right? We have to hold up our ethical standard, right? Just like a church, we don't want to tell people one thing and it be biblically inaccurate, right? We don't want to do that with our data. Okay. We don't want to make false numbers, inflate sales, all that stuff, guys. We don't want to do that because, like I said, auditing can come back and say you're wrong, you messed up big time. Another challenge is outsourcing, guys. A lot of big things in terms of using like consultants and stuff like that, right? A lot of companies will try and outsource their business, outsource their statistical analysis, right? They'll try and outsource it to a consultant and stuff like that. What this class really wants to teach you is, hey, don't outsource it. Let me do it. And like I said, you can show them that, and you can show them how much of a valuable asset you are. All the more reason for them to keep you. And then, like I said, another challenge, the biggest challenge, guys, communicating with numbers. Such a big deal, right? I want to squash the myth now, because I didn't mention it earlier, but I want to squash the myth now that math, you don't have to be good at math to be good at statistics, right? It's not just a bunch of number crunchers who sit at a computer all day and type, put in numbers all day, right? That's not what it is. That's not what math is either, but we have a preconceived notion that math is just this black and white, and it kind of is. It's this black and white, let's just find the steps to do, fill out the steps, make sure you show the work, right? Make sure the teacher's happy. But what statistics is, it helps you break out of that box that you can put math in, and it helps you kind of see it in a different light that allows us to kind of help, like I said, take numbers, find connections and correlations with those numbers, and helps you communicate that to your business, to whoever you're communicating with, right? And it kind of gets you to think up here a little bit. So that's a huge challenge that we have to overcome. We have to get out of that box of, I can't do math, so I can't do statistics. You can do math and you can do statistics, I promise. It's just going to take a little bit of critical thinking, okay? And that, like I said, critical thinking is huge, right? Statistics is all about it, right? Okay. But there's a lot of pitfalls that come into play with that, right? We can kind of we can think so hard that like there's certain pitfalls that we can fall into when it comes to thinking in this kind of way. So I just kind of wanted to go over these pitfalls so that way you can kind of avoid them. Not necessarily avoid them, because I don't want you to think failure is not an option, because I fail daily, okay? Failure is a part of life. Failure is a part of everything we do, right? I don't want you to be afraid to fail. But if we can kind of help steer you away from these pitfalls, right, it just makes it easier on you. How does the saying go? Those who forget history are doomed to repeat it, something like that. So let's not forget history, because these pitfalls are here for a reason, right? Somebody obviously did them, so let's not do what that person did, okay? First pitfall, conclusions from small samples. We never want a small sample size, right? Small samples don't mean anything. They're statistically irrelevant. They don't mean anything, right? So we never want to draw conclusions from those small samples. Small sample being one person, two people, stuff like that. If I asked you a question and you gave me an answer, that's a good answer. I'm not saying it's a bad answer, but if I was to draw a conclusion from that, how accurate would that actually be? You know what I mean? So let's not do that. Let's not draw conclusions from small samples. Conclusions from non-random samples. Every sample we ever take needs to be some sort of random sample, and we'll get more into how to sample, how to randomly select people, stuff like that. There's ways that you can do that. But we never want to draw conclusions from non-random people, right? If I'm looking for an answer to a question that I have, I'm not gonna find people who are gonna answer the question the way I want them to, right? I wanna pick people who are gonna give me their honest answer, who are gonna give me different opinions, different ways of thinking, different ideas, and that's gonna give me a better conclusion, okay? Conclusions, another pitfall, conclusions from rare events, okay? I don't even understand how that's a pitfall, because that should be obvious, right? If it's rare and it barely ever happens, why would we draw a conclusion from it, okay? That's obvious, right? Pitfall number 4, poor survey methods, okay? That goes back to kind of conclusions from non-random samples, right? We never want to sample non-randomly. We never want to sample the way that we want to sample, right? And we'll talk more about different ways to survey people, all that stuff. So we'll go over that more in detail next, but I just want to kind of go over that with you first. Pitfall number 5, assuming a casual link, right? It's kind of a casual link, like it's kind of making something up that's not actually there. You know what I mean? There's a definition called a post hoc fallacy, and a fallacy, it's just a fancy way of saying drawing a conclusion from insufficient evidence, I guess. It's kind of a mistaken conclusion based on faulty evidence, kind of. And that post hoc fallacy just kind of means like, it kind of just says if an event A precedes an event B, then A causes B, let's just say. A could be any event that happens, right? So if, for instance, you could say murder rates are higher during the full moon in Miami last year, right? Because of the full moon, murder rates were higher in Miami last year, okay? What about everywhere else, right? What about the places that the murder rate dropped in the full moon last year? The thing is, association does not mean causation, okay? We never want to assume anything. Just because there may be some sort of weird link in one instance, a lot of times it's not, there's no link there. So we never want to assume that kind of link. And you can kind of get that through different, like I said, different tests, different methods, stuff like that. You can kind of test for a correlation between different events. So that way we can kind of avoid this pitfall. Pitfall number 6, generalization to individuals, okay? The generalization that men are taller than women. That's a generalization, because on average men are taller than women, but there are women that are taller than men. So that's a generalization. We never want to generalize, okay? Just because the average height of men is taller, we never want to assume that that's true for every man, right? Because there are some shorter men out there. R.I.P. to Tom Cruise. Pitfall number 7, unconscious bias. That's a big one, because believe it or not, you may think you're the most objective person in the world. You have some sort of unconscious bias, right? It's in every single one of us. We always are objectively clueless when it comes to our own opinions and our own thoughts and all that stuff. So we want to avoid bias. You know what I mean? If I want to do a study of heart rate or heart attacks between men and women, I would assume that, it's assumed that men have more heart attacks than women, right? But actually, studies show that heart attack is the #1 cause of death for women. That's actually a true statement. So it's just easier to catch the symptoms in men earlier, and that's why doctors look for it earlier in men. That's why it's easier to catch. So that's unconscious bias, okay? We never want to assume anything because we've just grown up thinking that way our whole life, okay? And the last pitfall we can fall into from statistics is, and this is a big one, significance versus importance, okay? Just because you find a link between something, it doesn't mean it's significant, okay? Right, like let's say I'm married, so let's say me and my wife try and have a kid, right? We're not, but let's say we're trying, okay? If I read a study that kids on average are 0.6 centimeters taller in the springtime, would that make me want to go have a kid in the springtime? Probably not, because what's 0.6 centimeters gonna really mean? That's the difference between significance and importance, right? It's not really important what time we have a kid, right? What matters is is that significant enough to actually put out there to the world, okay? So we wanna differentiate between those two, okay? So once again, we're gonna pause the video. We're gonna go over some more points, more questions for you guys to kind of talk about as a team. I want you to team up, find somebody in this class, talk about the points, or the questions, excuse me. And these questions that they're really asking, they're asking about some studies, and I want you to kind of figure out what pitfall they're falling into, which one they're actually falling into. Okay, so when you talk about it, you'll discuss this as a team, and then you'll discuss this as a class with Mrs. Bernardi. So go ahead and pause the video, and we'll get back to it after this. I want to talk about the different types of data that we can have, right? Data sources, sample population, sampling methods, all that stuff. That's what we're going to cover in this chapter. So really the first thing we want to talk about is the different types of variables and data that we can have, right? So the one thing we always start out with, right, is an observation. It's just the single measure of what we want to find, right? It's the question that we ask, okay? It could be the thing we want to study, right? So a person, a firm, college, church, business, whatever it is, that's what we're studying, okay? A variable, I know we all know what a variable is. We've used them 100 times in math, right? It's just, it can be a number, and we don't really know what it is yet. Usually it's defined by X or a Greek letter or whatever, right? It's just a characteristic of the subject or individual. So it could be something we're trying to study, something we're trying to find. It could be anything, right? So a variable could be a person's income, or an invoice number, invoice amount, stuff like that. That's a variable. Lots of things. I hope it's pretty self-explanatory, but a data set is if I just have a bunch of numbers, right? A data set would be all of those numbers together. Usually they have something, they don't really necessarily have to have something in common, but a lot of times it's just the big pool of everything that we find, we put in a data set, okay? We'll be more specific in a little bit, but mainly that's just really what we want. We find data, that's our data set, okay? And it can have a lot of different variables in that data set, okay? It doesn't have to be just one singular thing. It can be like a person's name, their income, their job title, their company they work for, stuff like that. That's a data set, okay? And that goes with univariate data sets. And like I said, univariate means one, right? One. That's a one variable data set. Bivariate data set, two. And I think after that it just goes to multi, because they were tired of making up numbers or making up names. So it's a multivariate data set, more than two, okay? And so how do we, what are we doing with them, right? It can have mainly two different types of data sets, two different data types, and that's categorical data and numerical data, okay? Categorical data, pretty self-explanatory, right? What's my name? Excuse the handwriting, okay? My name is categorical data, okay? There's no numbers involved with that. There's nothing involved with it besides letters. That's categorical, okay? I'm not much older than you, but 24. That's how old I am, okay? Welcome to my life, right? That's numerical data, right? Numbers, really simple, okay? And we can have different types of categorical data as well. I guess I should move this over here. Let's move this. 24, okay? So we can have two different types of categorical data, right? We can have the verbal label, which is kind of what this is. This is a verbal label, right? Or we can have what's called a coded categorical data. And it can get a little confusing, but watch this, right? So if I ask a person in a survey what their gender was, okay? I can say enter 1 for male, and enter 2 for female, right? It's categorical data, okay, because we're asking them to identify male, female, right? But it's coded with these numbers, right? Don't get that confused for numerical data, okay? It's categorical, right? It's just coded, okay? So that's the different kind of data that we can have, right? It's pretty easy to differentiate between the two, right? This one, there's no number associated with it. This one there is, okay? The two different types of numerical data that we can have, discrete and continuous. And so in this case, discrete, it would be my age. I wouldn't really say my age, more or less, but categorical could be really just all the integers, right? And the integers are just, if you're not familiar with integers, it's just 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to whatever number, right? They're whole numbers, okay? That's what integers are. So as long as it's a whole number, it's discrete, okay? And continuous, right? I'm not gonna tell you a continuous number, but a lot of times it deals with like weight. If you're weighing something, right, you can have something that's, 150.5, 6, 7, 8, 9, and on and on and on, right? Because we never can get the most, we can never get it, right? So that's what's called a continuous numerical data, right? Because we can never get this to the exact number that it is, okay? Same with distance, right? We can go 1.678259 miles, but we can never get down to the precise measurement of distance, okay? But we can always, like I said, we can always cut it off here, right? And it can look like it's discrete, but like, hey, this is, 150.56 pounds, but that there's probably more numbers added onto that. It's still gonna be continuous. Don't let it fool you, it's not discrete, okay? But if I was to ask you, let's say, hold on. Yeah, so normally you can kind of identify discrete numbers with, in the survey, it starts with number of. So if you say number of students in the class, right? 7 of you, 8 of you, okay? That's discrete, really easy to remember, okay? If it says number of, fill in the blank, you can bet it's probably gonna be a discrete discrete numerical data. Right, if like I said, weight, time is another one, yeah, that's another good one. Usain Bolt, one of the fastest humans in the world, ran a 100-meter dash, 9.58 seconds, something like that. I don't really know. Don't check my math, but it wasn't 9.58. It was probably 9.58 blank blank blank. Something. But they were going to round it up to the 100th decimal. So really easy, but people can kind of go back and forth, and people can get confused on it. So it's really important to kind of differentiate between these two. So this is where we pause the video. Way to go. You made it through another section, but we're going to do some examples, some problems for you guys. Team up, talk about them. This is really just differentiating between categorical data, numerical data, and the 4 different types we have. Okay, so get with a partner, talk to them, and then we'll discuss as a class. Okay, so pause the video, and we'll get back. Okay, so we're back. I hope you guys were able to figure out the problems, talk about them, discuss them. But moving on, so we talked about types of data, the different, categorical, numerical, all that stuff. So now we're going to talk about the different kind of concepts of sampling. Okay, how do we sample? Different ways that we can sample, stuff like that. So first things first, I want to talk about the difference between a sample and a population, right? Because you can sample both, right? You can sample a sample and you can sample a population. But let's differentiate when we should be doing that, okay? So obviously a population, right? The population of the US is a lot. I don't really know. I think it's like 320 million people, something like that. It's a lot of people, okay? If we were to survey 320 million people, you know how long that would take? That's my point, okay? We could take a sample of the population, right? Where it's we can sample the people in just the state of Arkansas, which is still close to 3 million, something like that. It's a lot of people still, but it'd be a lot more manageable than 320, okay? So the population is just the thing, the amount of the group of people that we're interested in. So all of the people that we're interested in, right? But the sample is the subset of that population, okay? And a lot of times we'll take a subset of that sample if the population is like an infinite population. So let's say like a manufacturer of a Tyson plant, right? They do a lot of chicken, a lot of stuff. I used to work actually for a conveyor technology. They did a lot of things with the conveyor belts that ran those the plants and did all that stuff. So I'm familiar with a little bit of their work. But for instance, like if I was to try and take a sample of the population of, the amount of chicken that goes through the plants I guess not even for a specific time period, but just as overall, I couldn't calculate that number because they're constantly running the plant, constantly manufacturing more of the Tyson chicken that we eat, right? So there's no way to actually get an accurate number of that population. But I could take a sample of that and say, what's the number that they produce in a month, right? I can. It'd still be a big number, but I could actually put that into, there'd actually be a cap on that, okay? So that's the difference, right? That's when we probably want to use a sample between a population, right? But like I said, don't make conclusions from a really small sample because we never want to do that, all right? But we could take we could sample a population if it was a small population, like I don't know the smallest town in the state of Arkansas, but there's probably a town out there with 180, 200 people in it. You could easily take a sample of that population, okay? That's the whole population. We can take a sample of it because it's really not a huge feat to do, right? But if it's 1 million people, that's a hefty ask, okay? So just kind of making your best judgment onto when to sample the population, when to sample or when to just do a subset of that, okay? Sorry, I forgot to erase this from last time, okay? So the next thing we're gonna talk about is statistics. Hey, just kidding. But parameters, right? What are parameters, okay? Like I said, we can take a sample of a population and then we can take a sample of the subset of that, right? And if we were trying to find the mean of both, right? Mean is another word for the average, okay? If we want to take the average of that, we'd have to have two different symbols, right? Those are parameters, okay? So like, let's say I want to take the population of a whole town in Arkansas, 250 people, right? And I want to find the average, okay? So the population is 250. I want to find the average, right? I would denote it as, more times than not, they're denoted by a Greek letter. So in this case, this is the best Greek letter I can come up with, okay? I think this is mu or something like that. I don't know. Don't quote me. But this is the mean of the population and equals blah, 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 okay? Right, but if I want to take a subset of this population of 250 and I want to say I wanted to survey 50 people from that about a different thing, okay? or it could be the same thing. You just wanted to get a more accurate or a smaller sample. Okay, I can't use this anymore. Okay, I'd have to use a different one. So a lot of times they'll use this for the population, and then they'll use what they call X bar as the mean for the sample. Okay, so we have to make sure we denote which is which, right? Because if I was to look, like I said, this is another thing, importance of communicating with numbers, right? We have to be accurate. We have to make sure that we know or differentiate between the two means, right? Because if I was to look at this and you use the same symbol, I don't know which is which. Okay, so you have to denote that, right? Standard deviation is another one we'll learn about probably in a future class, future video, okay? Standard deviation is often denoted by this, okay? So since this is the symbol we use for the population, we can't use this for the sample. We have to use something else. I don't know what we could call this, Y bar. Let's just call it that, okay? It doesn't necessarily have to be a Greek letter. It's encouraged though, I guess. But anyway, those are parameters, okay? That's the importance of communicating with numbers. All right. Okay. All right. So we talked about this. Talked about sample, population, all that stuff, guys. So we're gonna pause the video again. We're gonna run through a couple problems. I want you guys to talk about this, discuss. I think this time we'll just discuss it as a whole class. Okay, Mrs. Bernardi will kind of facilitate the discussion. Let's talk about these. Okay. So really what we're going to do is just kind of talk about if we should use a sample or a census, right? Take a sample, a subset of the population, or if we should just survey the whole population, okay? So pause the video, let's talk about it. We'll get back with you. All right, we're back, cool. This time, let's talk about, we're going to get into some sampling methods. This is just ways to pick which people you're going to survey or which people you're going to obtain data from. So we have some random sampling methods that we could talk about. Like I said, just a simple random sample. Simple random sample means I'm just going to pick people at random, right? If I have a list of people, I'm just going to pick, I don't know, you could do it a number of ways. Just pick random people on the list, right? Or I could, ask one of you to raise your hand. Or not even raise your hand, I could just pick on one of you. That's a random sample, okay? I would do that obviously because I'm here and you're there, but you get my point. I'll have Miss Bernardi do it. And like I said, there's also ways, like calculators, especially calculators nowadays, most TI calculators now have a function where you can have them generate a random number. Excel has a function where you can generate a random number. Google Sheets, I'm pretty sure, has the exact same function. So if you're not sure how to randomize a sample, Excel can do it for you. So work smarter, not harder. And in a random sample, you can either sample without replacement, you can sample with replacement, and those are pretty self-explanatory. Without replacement means if you use it, you can't. If you use it, you lose it, right? Can't replace. You can't put that person back in the pool of people to be picked out. Okay. Sampling with replacement is kind of like the function like the calculators do, the Excel, that stuff. They will do sampling with replacement, right? They can use the same number over and over again in a random sample. Okay. So just be wary of that. If you know, like, hey, I want to sample this person or sample this data set or this subset of people, you have to differentiate between whether you want multiple answers from or multiple sets of data from the same person, or you want to survey without replacement, right? I know sampling without replacement is a really popular one. A lot of people don't want the same number coming up over and over again. So that's definitely important, but you get my point. There is a systematic sample. Systematic just means I'm going to sample every 5th person, every 10th person, every 15th person. so on and so forth, right? It's just systematic, okay? You follow a pattern. And there's different ways you can do that too. It doesn't have to be just every fifth person, right? You can do something like that. The next kind of sample we can have is a stratified sample, and this is just kind of a way to help focus your survey, focus your data. You can take a survey of the population, and then you can, if you know if you know, like, you take a survey of 200 employees of a company, and you know that the ratio of the company is 55% male, 45% female, right? You can then weight the observation or the variable that you're studying. You can weight that based on the proportion of men to women, right? So you can then you can find what you're looking for and then weight it based on the proportion of men to women. So I know that may be a little confusing. It's not the most used, but it helps with reducing error, and it increases, it just increases efficiency. So that's another way to do it. But another sample type is a cluster sample, right? Just picking groups of people at random, like usually from like geographical regions. So like I'm gonna pick a group of people from this area, I'm gonna pick a group of people from this area, this area, this area, and then we're gonna survey them, okay? So just making it kind of a cluster of people in the same area, but they're in different regions. So it kind of nullifies that in terms of, and it kind of makes it a little bit more random. But like I said, this is kind of really inefficient, and it would cost a lot. The cost of doing it, especially with distance and all that, it's just not really that efficient. So it's not used a whole lot, but it is done some. There are some non-random sampling methods that are okay. I know I said don't make conclusions of random surveys, but there are ways to survey people non-randomly, okay? And it still be okay. First one is a judgment sample. Using an expert, they can kind of make a judgment on, hey, I want to survey these people based on this knowledge of, this company, stuff like that. So using that expert knowledge, again, though, keep in mind there's a pitfall there that can happen. I hope you guys know. If you know what it is, you can scream it out, but I'm going to tell you anyway. Probably unconscious bias. There can be a lot of bias in that judgment, okay? So it's just something to be worried about. Another one is convenience, right? Convenience. If I wanted to take a survey right here, right now, I could ask all of you a question. You all have to give me an answer. That's convenience, right? It's the most readily available to me, okay? Is it the most efficient? No, but I have an answer right now that I can use, okay? That's probably one of those ones where you don't want to draw conclusions from small sample sizes. Pitfalls can come into play. Like I said, I'm just kind of, running through this right now, but, it's just different things to think about, right? If you need an answer right now, this is probably the best way to do it. Convenience, okay? Another one is focus groups, right? I know a lot of people, we use focus groups in our business to test, like, pilot things out. So, we're trying to lighten our workload because we're so far behind right now. Don't tell them I said that, but we're behind, we're busy, okay? So we have focus groups that we kind of test with these pilot features out for software. They can kind of help make processes faster. Hey, there you go. Always tying it back in and relating it. So, just helps make processes faster, makes our workload lighter. But these focus groups, they really are a small kind of group. It's like a 5 to 10 people selected. Usually they're very it's a heavy screening process. To kind of pick the people they know that they need. It kind of helps weed out what they don't want, and really helps the focus group kind of, it narrows the focus. So that's another way of non-random sampling, okay? But again, there's bias in that. There's all different kinds of pitfalls you can fall into, so you have to be wary of that when doing a focus group. But they are efficient if you know what you're needing and you know what to kind of look for. So like I said, guys, this is all in the book. I encourage you to read it. If you have it, I would encourage you to read along with me. But all this is in the book, guys. So please feel free to read it. It goes into more detail than I'm going into. This is just kind of a quick summary so you guys can have some background knowledge before we really get down to the nitty gritty. We're going to get into like different sources of error. So like I said, with all these different sample sizes, we can run into a lot of errors, right? Whether it be non-response bias. If someone says, I just don't want to answer your question, that's non-response. We can't use that data. It's really hard for us. That's an error, okay? Selection bias. That goes with judgment sample, right? I could select the wrong person to interview, to survey, to get data from. And it could throw off all of the analysis, okay? Response error. If someone gives me just an absolute absurd answer, I can't use that, okay? Measurement error. I could analyze it wrong and I could put the wrong measurement. Again, that goes with imperfect data. I never want to give someone 90% of a photo. I need to make sure that my measurements are right, okay? But there is, like I said, no one's perfect 100% of the time, so we just want to do our best. So, but measurement, there can have some error in there, okay? The big one is sampling error, okay? Sampling error, it happens more times than probably any other bias or any other error, but a lot of times we tend to think that our sample size is good or the way we pick people is good, but we can mess that up more times than we probably get it right. So we want to make sure, extra sure, that our sampling is on point, okay? Okay. Next thing I just really wanted to quickly hit, data sources. You know, a lot of people probably ask like, well, I don't even know where to get this data. Where do you find it? Well, where do you go when you don't know something, right? What's the first thing you do? You get on a computer and you go to Google, you go to Yahoo, go to Bing, any search engine. You can type something in and it'll pull up 100 different pages on what you're looking for, right? That's a data source, okay? Where we go to find the data we're looking for, that's a data source, okay? Really easy. Now we have smartphones that do it for us. Real quick, I just want to hit surveys. The way we collect data is by surveying people, right? And so it's really an important aspect to data collection, data analysis, all that stuff. And so really what we want to do is we want to make sure that our surveys are the best that they can possibly be, so that way we can get the most accurate data, all right? And so there's really 5 different main types of surveys. We can have a mail survey, M-A-I-L, not M-A-L-E. I guess you can have a mail surveyor, but you know, I don't know. M-A-I-L survey that comes in the mail. You can do it over the telephone. I doubt you'd ever talk to me over the phone, but you know, you can do it that way. You can just do face-to-face interviews. You can do it over the web, and you know, and then there's direct observation. Okay, you don't really have to survey them. You just observe them and kind of figure it out that way. Or I guess it can be done in a controlled setting is what I really mean. Some would classify that stalking if you didn't do it in a controlled setting, I'm sure. So don't do that. Questionnaire design, we always want to design our questions and fit the design of the survey to how we want to steer our data, okay? That's a really big, important part of surveying. We want to make sure that you know, we're asking the right questions the right way, wording it the way we want it to, because you know, a lot of times people can get confused if we word it weird, and it throws off all the data. So we want to make sure we're precise, efficient, and word it correctly. And you guys can kind of go through that in this book. I'm not going to hit that, but that's the end of chapter 2. Let's get on to chapter 3. Chapter 3, guys. This is where we kind of get into a little bit more fun stuff. Instead of just listening to me talk all the time, we actually get to draw some stuff. So Chapter 3 is just describing data visually. What does it look like to visually put data on a page, right? And the main way we do that is by graphs, whether it be bar graphs, pie charts, stem and leaf plots, all that stuff, guys. We're gonna learn that today, or learn that in this video, okay? So really the first one we wanna talk about is a stem and leaf display. Now what a stem and leaf display is really just kind of like a frequency table, right? So you have, I don't know, let's see, you have, you have your, we start out, we build, first thing we want to do, we build the table. We build the table, right? We want to put the data down. We want to build the table, okay? So we want to start with the frequency, okay? And then our next thing is the stem, and I'll talk more about that here in a second, but, and then we have our leaf, okay? So our stem is the beginning part of the data, all right? So let's say I have, I'm collecting data on the age of a certain town, okay? That's a simple survey, okay? So I have the age of a bunch of different people in a very small town in Arkansas. So what I'm going to do is the stem part of this is the first number of their age, okay? So I have 0, right? Anyone from the age of, I guess, 0 to 9, right? And then I have 1, 2, 3, 4, 5, right? Apparently there's nobody in their 60s in this town, okay? So the next one, the leaf, is the next letter, or the next number, in that data, okay? So let's say there's someone who's 2 years old, and then 6, 8, right? So on and so forth. So we have a 12-year-old, or, sorry. Let's just say we have a 10-year-old, a 12-year-old, a 16-year-old, an 18, hello. See, it's okay to get it wrong sometimes. A 17-year-old and a 19-year-old. Okay, and so on and so forth. Right, we have to have some, I feel like we need more older people because I don't know where all these young cats came from. But you get my point, right? And then so you write all this data down and then you count the frequency, right? The frequency is how many times do these numbers show up, right? So I have 3, right? The frequency of people between the ages of 0 and 9 are 3 in this small town, okay? 1 is 1, 2, 3, 4, 5. Let's see, 5 in here, 3 here. Let's just say 7 here, and I'll say 16 here, okay? All it is how many times the numbers show up in this plot, okay? If this is just the frequency, all right? That's a simple stem and leaf plot, right? And it may seem kind of like unimportant. It may seem like, why is this even a graph that we use? Well, if you can look at it, you can see, well, there's a lot of old people here, right? There's not as many, there's more people in their 40s and 50s than there are people under their 30s probably combined, right? So that would tell me if I'm, if I'm looking to start a business, I may want to cater to this older demographic, right? So this just kind of helps us see that visually, okay? That's what a stem and leaf display is, all right? A dot plot, kind of the same format. If you didn't get this down, rewind the video. A dot plot it has the same kind of setup, just a different visual perspective. So a dot plot is really more horizontal, whereas the stem and leaf is kind of vertically lined out. So the dot plot kind of just has it looks like a ruler right here. let's say this is, I'll say 60 here, 60 here, 0 here, 10, 20, 30, 40, 50. Now I understand this isn't evenly spaced out, right? We want to make it look pretty. We want to make sure that it's evenly spaced out, but cut me some slack, okay? And we can just, and this is in in increments of 2, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth like that, okay? And I'll just go ahead and finish this. Okay, so 2 increments of 2, right? And I wanted to display this, the data we had originally, right? The ages of people in small town Arkansas, and I wanted to display it on this dot plot here. Right? So what I would do is I would say, okay, well let's say I have, it's really easy, you have to draw dots. I have 4 10-year-olds in that city in Arkansas, right? I have 3 22-year-olds. I have 1 20-year-old, and then I have, I put it in the middle between 2 slashes. That means, if you can guess, I have a 33-year-old, okay? 40, all right, I'm not gonna fill this out completely, but you get my point, right? It's just putting dots on the numbers that represent their age, okay? It's really simple. Like I said, it doesn't really look statistically all that impressive, but this can tell you a lot, right? So if I have a lot of people, let's just say I have a lot of dots here, right? All over the place, right? Once again, if I'm starting a business, I can tell you that a lot of the people are between the ages of 20 and 40. I want to cater to those 20 to 40-year-olds, okay? Just helps you see that data visually again, right? So that's what a dot plot is, all right? On to the next one. Actually, you know what we're gonna do? We're gonna stop the video here, and you're gonna get to draw some more dot plots, stem and leaf plots, stuff like that. So this one you can kind of do by yourself because you don't need a partner to draw a graph. But if you need help, Mrs. Bernard is there. You can talk to people and we can figure it out. So pause the video, work a couple problems. We'll be back soon.